Everybody, so in this video I'm going to be talking about the principle of conservation of momentum and just apply it on this problem that we have here. So to begin with, all right, the conservation of momentum, the equation would be, let's say we have two masses, mass A and mass B. So we have mass A times its initial velocity. Okay, so the initial velocity plus mass B times its own initial velocity is equal to mass A times its final velocity plus mass B times its final velocity. So this is like our initial state, okay, the initial state, and then this right here would be our final state. All right, so there's like we have something going on initially, and then some collision happens, and then we are left with a different state that has different velocities and different, yeah, just different velocities. But in this case, we're not going to be dealing with direction. If you're dealing with a 2D problem, you're going to break it up into x components, and then you have the same equation but for y components. But in this case, we're just on one straight line, not having to worry about that. So let's go ahead and begin with this problem. So I'm just going to refer to the bus as the first object. Okay, so I'm just going to call it object 1, and the car is going to be object 2. So what's going to happen here is they're describing the situation to be a inelastic collision, where we have the bus, okay, traveling to the right. We also have the car traveling to the right, but the bus is traveling at a faster rate. Okay, so that is our initial state. Initial. All right, and then the final state, what happens is that they combine. Okay, they crash and become entangled, as they say, and it's an inelastic collision. So now we have the bus plus the car all into one mass. Okay, so this would be mass A plus mass B, right? And then they would have their shared velocity. So here we have mass A, which is the bus, traveling alone, mass B traveling alone, and then finally they combine. So let's just go ahead and begin with the problem. So, all right, we have mass 1. So the mass of the bus, I'm going to convert it into kilograms, and that would be 5,400 kilograms times its initial velocity, and that which is 20 meters per second, plus the mass of the car, which is 2,000 kilograms, times its velocity, 16 to the right. Okay, so my sign convention is the right being positive. They're both moving to the right, but just the bus moving at a faster rate. Equals, so as they say, they become entangled, they share the same mass, inelastic collision. That means that they're going to have a combined mass. So 5,400 plus 200 is 7,400 kilograms, and then they're going to have their shared velocity. So all I have to do right now is multiply and then isolate VF. So once I plug that into the calculator, I get, all right, so that would be a final velocity of 18.9189 meters per second. And then depending on how many significant figures you want to round to, whatever, let's just leave it to 3. So that would be 18.9 meters per second.